All right. We want to break this polygon into things to find simpler area. Guess what? The polygons I'm going to have you guys break down are a little simpler than finding the area of a whole kitchen. Someone want to come up here and draw a line? Where should I draw my line? Go ahead, quickly. We want to break this polygon down into simpler areas. Okay, now, he chose the harder of the two versions. Yes, I'll show you why. Now, it works. You can do it. This can be done, right? Tyler, this can be done. But we have to do subtraction in order to do it. So let's find the area of, first of all, we got this triangle in green, and we have this, or not triangle, rectangle in green, and we got this rectangle in red. How do you find the area of a rectangle? Length times width. Okay? So the rectangle in green. What is the length of the rectangle in green? 3 times the width. 2.1. Can someone multiply those together for me with a calculator quickly? Or 6.3. You don't need a calculator. Great. 6.3. That's for that one. Now the one in red. Uh-oh. This one's a little harder, isn't it? We can have the width here. The width is 1.7, isn't it? But now we need the distance from here to here, which we're not just given it, are we? What do we have to do in order to find this? Because from here to here is 4.9, but from here to there is what we're looking for. Do we know the distance from here to here? Sure we do. So yeah, let's go 4.9 minus 2.1 is 8, 2.8. So this is 2.8. Now we got to go 2.8 times 1.7. And what do we come up with? You guys all had a calculator before. Come on, pull it out. Help me. I don't mind you using calculators. Let's do it. $4.6? 7.6? Okay, add them together. What's the total area of this polygon? What's my label? Centimeters squared. Okay? You think you guys can do a shape like that? It's pretty easy. Now, check this out. If I drew my line here, it's easier because we have a base and we have a height, or a height and a base for that one, and we have a base and a height for that one without doing any subtraction, and we don't even worry about that 3. Yes? Whatever. You didn't see the dot? Look for the dot. That's a tough one. Tamasha, do you want to draw a line here, how we can break this one down into simpler shapes? Come here, draw a line. Uh-oh. Don't be scared. Don't be scared at all. Where should we draw a line? Whatever, man. There you go. We could do that. That one works. You know what else we could have done? We could have done this. And the way Tamasha did it gives us a triangle and a rectangle, right? What does this give us? Rectangles. Let's forget about Tamasha's line for a second. What does that give us? What are those two shapes? There's two of them. What are they? What are they called? Two trapezoids. Do we know how to find the area of a trapezoid? Sure do. So we could find the area of one and just multiply by 2 or whatever. But I like Tamasha's way because it's easier. Okay? Tamasha's way is easier. Yes. Scratch sheet of paper. I want you guys to do this. Quick, go. Or if you want to do the trapezoid way, do the trapezoid way. Both ways work. I will come around and see if you're going after it right. Why 28? Look, the plan for this one is you could either break it into 2 trapezoids and figure out the area of one of the trapezoids and figure out the area of the other one and add them together. That's one plan of attack for this. The other plan of attack for this could be that you could find the area of the triangle here, and you could find the area of the rectangle here, and then just add them up. Okay? So, Craig, what did we find for the area of this rectangle? 672, because we took 28 times 24. The other thing then, we have to find the area of the triangle. And when we broke this down, we went from here to here. This is 24, but from the whole thing is 36. So that means from here to here is 12. So now we have a base of 28, a height of 12 for the triangle. Once we broke that down, what did we come up with the area for the triangle? What was that? 168. So we got the triangle at 168, we got the rectangle at 172. We add them together, we end up with 840 square feet. All right? One other thing I want to show you, and then I'm going to give you your assignment. It's only 4 problems. So the last thing I want to show you is you're going to have problems that look like this. It's going to say, Patrick made a design. Use the coordinate grid to find its area. A lot of you are going to want to count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then call it 10 and call it good. That's not good, is it? Why? Somebody tell me why that's not right, Craig. Why is that not right? So what's the area of each one of these squares? Not 5, because it's 5 by 5. It's a rectangle, it's a square. So each one of them is 25. It's just like that square foot and square inches problem. How many inches are there in a square foot? It's not 12, it's 144, right? How many square units are in each one of these squares? 25. So you got 25, 25, 25, 25, 25, and so on. You end up with 250 because there's 10 of them. I know you had an answer. Okay. Your assignment. Page 553. Numbers 4 to 7 all. And you can do number 9 for extra credit.